Okay, so we can go ahead and get started if you guys are ready. So first of all, please make sure that you have RStudio open. So not R, you need to have R and RStudio installed, but make sure that what you have open is RStudio. So it should look similar to what I have up on the screen here. Okay, so another thing I was just about to say that if at any point you fall behind or you get an error, please raise your hand. I want to come help you. If you don't at any point get an error through this process, I will assume that you're lying. So please, if you get stuck, let me know. I've built in plenty of time for there to be many mistakes. First thing though, if you get an error, check your commas. That's the number one where the errors come, at least for me, is I'm missing a comma or the comma's in the wrong spot. So check, make sure that your commas match mine, and if that's not the case, then let me know and I'll come around and help you. Okay, so first what we're going to do, does everybody have RStudio open? Okay, good. So we're going to go up to File, New File, and then RScript. So the reason why we want to use an RScript is so that we can keep our code and we can reuse that code. If you're working just down in the console, then it'll just be in your history, but you might not necessarily be able to if, in 2 days you realize, oh, I made a mistake, I need to rerun this code, you won't have it. So that's why we always want to use an RScript. So when we are working, we'll work up here, but in order for it to actually run, you have to either hit Command-Enter, which is for a Mac, or Control-Enter on a PC, which sends it down to the console. So the console is where it actually will run and do its thing, but up in the script is where it'll save, and you can edit and do things there. So the most basic thing you can do with R is use it as a calculator. So you guys can just follow along and type in 1 plus 2, and then hit Command-Enter or Control-Enter, and yes.
Because I can see all the people trying to catch up. And so R is the program that is doing all this stuff. RStudio lays on top.
Yeah, so it's the user interface. So R is the language, and it's interpreting and translating your code into what translates with the computer. But RStudio is the really nice user interface that allows us to see what we're doing and work with it really nicely rather than just typing in pure code. Great, so we want to be using RStudio, have that open, so it should look something like mine. Okay. Did you have a question?
I was just going to say, when and where should we save stuff?
I like to, so what I do when I'm saving is I like to save it as a whole new file. Once I get code that works, I save that and I don't touch that file again. And then I copy and paste it into a new file and call it something else what I'm adding. So for example, when I was creating a Shiny app for Dr. Hart, all of my files were like added table, added whatever. So I always had that original file. So if I screwed something up royally, I knew that I had one step back, I had a file that worked. So I suggest doing it that way, but some people like to save over the top of what they're doing. It's just personal preference. Okay, so did everybody get it to run a 3? You got a 3 shows up down in the console area? Okay, so R is an object-oriented language, which means that you can save values to an object so you can call on those objects later. So for example, if I wanted to say A equals 1, run that, and then in order to do an object assignment, you can also use an arrow. So I could say B and then arrow 2. So that's just personal preference, whichever you prefer. I use equal signs just because it's one key instead of 2 keys, so that's what I do.
People use the arrow.
Right, but so I wanted to show you guys what the arrow was, so if you prefer that, or if you see that in somebody else's code, you know that it's the same thing as the equal sign. So then, now that we have saved those values into those letters, those objects, we can now call upon those and say C equals A plus B, and then if we run C, you'll see that now it's 3 because it used those values to give us the value that we added those together. So another way that, yes?
Does there have to be a space after the?
No, so that was something, thank you for bringing that up. I was going to get to that. So spaces, you can have as many or as little spaces as you want. R does not recognize spaces, but what R does recognize is capitalization. So we're gonna get that soon. But yeah, so it doesn't matter. You can have 100 spaces in there, and it'll be exactly the same as if you had no spaces. Okay, so if we wanted to use a function called paste, what paste does is it connects multiple things together, and it'll print it out in the console. So if we wanted to say A, and then comma is how paste, this particular function separates what we are putting into it. So we're going to say A, comma, and then we have to put quotations around the plus sign because I'm saying I want the character plus, not the operator. So I'm saying I want you to literally print out a plus sign. I do not want you to actually add things together. So that's why quotes is telling it I want a character in quotes. If I were to put A in quotes, it would print out A the letter, not A the value. So what we wanted to print out now is a 1. But if I were to put quotes around A, then it would give you A the letter. So we'll say A, B, and then we'll do equals C. So if we run that, it gives us this nice, neat equation that prints out here. 1 plus 2 is 3. Yes?
So I was able to start an R script and put 1 plus 2 into the text and then put enter, but my console still has a bunch of like copyright stuff.
Yeah, so you can, does it have copyright and your stuff or just the copyright? So if it just has the copyright, that means that you haven't run it. So you've just typed it into the script and not hit Command Enter or Control Enter, depending on a Mac or PC. So you want to make sure that you hit that. And you can also clear, if at any point you decide it's getting too much, I have too much in my console, you can hit Control L, and that'll clear everything in your console. So you guys can go ahead and hit Control L, and it'll just clear that out for you so that if you made a mistake or whatever and you don't want people looking over your shoulder that you have all these errors, you can just hit quick Control L. Okay, so any other questions so far? Yes?
Could you explain how the hard enter works when you're running the code?
So the Command Enter, Control Enter?
The lines that runs by line?
Oh, okay, so yeah, so you, each line is a separate operation. So if I were to, I can run multiple lines by highlighting and either hitting Command Enter or clicking this Run, and it'll run both lines. But as you can see, it has this caret, which is R's like I'm beginning object. So it'll say like I'm starting a new thing here. If you can have, if you put a plus at the end, you can like continue in multiple lines, but we'll get to that a little later. That's little.
So if you used SPSS, you're used to a period to end the command. If you're used to SAS, it's semicolon. But here it's a line.
And you can, in R, you can do a semicolon as well. And if you put things on the same line and put a semicolon in between it, it'll treat that as you're doing a space. So they did that for a lot of coding languages use the semicolon, so they did that. So if you're coming from a different language, you can kind of do that as well. But in R itself, it's just you just hit enter and it's a new line. Okay, any other questions as we continue on? Okay, so next I'm going to talk about creating a vector. So what a vector is it's just an object that has multiple values in it. So for example, if I want the object to be called names, and then we're going to use this C function. C is going to combine multiple values into this one object. So C, I like to think of C as standing for combine. So we're going to use that. And then, so names, we have to use quotations because if we were to just write Ashley, then it would assume that I'm calling an object that I've previously named Ashley, but we haven't. So I want the character string Ashley, so we're going to put it in quotes. And then Caitlin, which is my sister's name, and Colleen, which is my mom's name. Okay, so right now this is just a vector with 3 names in it. Yes. Did I? Oh, okay. Oops. So Caitlyn, not TL. Good thing you're here.
Take back my aw.
Okay, so now that she has done that, I'm going to give her age out to everybody, so be ready. So I am 23, and my sister's 25, and my mom's 53. So, yes. So right now, these are separate vectors. They're not connected to each other. So right now, R does not know that Ashley goes with 23. So I'll show you how we're going to get to that, but I'm going to add one more. That is birth month. And notice that I capitalized the M. And if I didn't, it would be something different. So let me show you that in just a minute. So I was born in May. My sister was born in June. And my mom was born in January. Okay, so make sure first that you've run all 3 of those lines, because if you didn't, then they haven't run and communicated through R. So make sure that you see all 3 of those in your console. So if I were to type in birth month, I would see May, June, January, which is the vector that I just created. But if I were to type in birth month with a lowercase, you'd see object not found. That's because R treats letters, capital A is different than lowercase a. So if I wanted to call my A that I said previously, that we said 1, if I put a capital A there, it would be thinking I'm trying to call something completely different than the lowercase a. So keep that in mind as well as we're working with this. So like I said, these 3 vectors are not connected. They're just separate values. So if I want them to be connected, we can make a data frame. So I'm going to call the data frame practd, just for practice data set. And then we're going to use the function data.frame, which is making a data frame. So it's a really nice name. So it makes a data frame, the function data frame. So what we're going to do is put in, with comma separated, we're going to put names, age, and birth month, and make sure you use the capital M. So then when we run that, we can see that now we have a data frame where they are connected, and it shows that it's in a data frame rather than individual vectors. Yeah, Sarah?
Does it matter if we have spaces like names, comma, space, age, or names, comma, like
No.
space, age?
Nope. The R does not care what you do with spaces, except in, I shouldn't say it doesn't care about spaces at all. If you have spaces in your variable names or in your column names, once it hits a space there, it thinks there's like a new thing coming. So you can't have, I couldn't have pract space D, then that's not one object. So it doesn't care about spaces in most respects, but if you're trying to do a name or an object or something like that, then it can't have spaces in it. Okay, any other questions on what I just did? Yes?
Just to make a comment that probably the most common type of data you're going to use in here is called a data frame. Okay, that's what's most similar to what you're used to working with. When it has the columns, headings, or the names, right? The rows are the data. There are a number of different ways to store data in R.
Right, so you could use a matrix or something different, but what you are used to as a data set would be considered a data frame. But there are, yes?
This is a little bit unrelated, but I was wondering, why can't you initially make the birth month all lowercase? And then
Oh, you can. I just did that as an example of showing that the capital M and the lowercase m are different. that's all I was doing there. But yeah, you can. I could have called it Timbuktu. You could call it whatever you want. R doesn't know the difference between age and elephant, so you can just call your variables whatever you want. That being said, you should probably call them something that you can look back 2 years from now and be able to recognize what your variables are called. So I know that a lot of people who are familiar with coding, they look back on their code and they're like, I'm not sure what this was. So it's helpful if you either annotate your code or use very good variable names so that you can recognize what you're doing. Yes? It's the pound sign or hashtag before the line. So you can, I can either put it here and do that, or I could put it at the end here and do that, but then everything after that. So I couldn't then write code here. It's everything after that is, you're welcome. And for those of you who came in a little bit late, make sure that you're working in RStudio, not R. So I know sometimes that can be a little bit confusing. So you want to have both R and RStudio installed, but we're working in RStudio. Okay.
Mine isn't always creating objects.
That,
I ran practice D and it's not popping over into my global environment on the right side.
did it show up down here? No. Okay, so then what that means is where you ran this line, you didn't actually run it so that it comes down to the console. So if it's just up in your R script, then it's just like you just wrote a letter there and never mailed it. So you have to actually hit Control-Enter so that it'll actually send it down to the console. Did that solve your problem? No? Okay.
Nope.
Let me take a
It's
look.
running it and then it's just So I tried running this and it shows it down here.
Okay, so what you can see how there's no caret in front of there?
Mm-hmm.
That shows that it's not, because you had an error up here, it's like it's not done. So what I usually do is just type in a random thing that it'll give me an error so that it's not thinking you're trying to give it more information. So just type in like random letters, hit enter, yep, hit enter, and it'll, I don't know why it's, your caret is gone. Do you wanna? Can you come? Because I don't know why his caret's gone. Okay. So any other questions before we continue on? Okay. So we're gonna start with something that's a little bit difficult. We're gonna do a for loop. So this is one of the major things in coding. So what a for loop does is it allows you to run through something multiple times. So if I said for I in 1 through 3, so the colon is saying through. So it's 1, 2, and 3. That's just a faster way than I could type out 1, 2, 3, but it's saying 1 through 3. And then we're going to use the curly brackets, which is saying inside the parentheses, it's saying here's my condition that I want to be true, and then in the curly brackets, it's saying do something. So we're just going to print I. So print is just a function that'll just print it down to the console. Okay, so we want to make sure that we're running the entire thing. So we have from the for to the last curly bracket. So highlight that whole thing and either hit Command-Enter or hit the run. And then you can see it ran through and printed out 1, 2, 3. So how a for loop works is it says for I is just integer. They just use I in coding just because, I don't know, because it's integer. So for I in 1, 2, 3. So you're going to start with 1 and you're going to run through it and it'll say print 1 because 1 is now I, and then it'll have 2 for I and it'll say print 2, and then it'll go 3, print 3. So that's how a for loop works. So why would we want to use anything like this if we wanted it something a little bit more complex where you're going through and you're checking or you're doing something like that? then you'd want to use a for loop. So let's, based on the practice data set that we just made, let's do for j, and j is just like I, but you never want to use the same value. So in coding, when you're doing for loops, you just do I, j, k, l. Again, I don't know why. So for j in names, so names is the vector that we had made earlier. So we're going to use that. So it doesn't have to be numerical values. It can be the first element in that list, the second element in that list, the third element in that list, and it'll run through the number of elements you have. So now let's do an if statement. So what this does is it says if something is true, then do something else. So we're going to say if j is equal to, so we're going to use double equals. So previously when we were using equal sign, we did a single equal to say set a equal to 1. Now the double equals is saying is j equal to something. So when you're doing a single equal, that's saying set it equal to make it that way. And a double equal is asking is it equal. So it's more of a question. And you'll get a true false as a response. So we're going to ask if j is equal to Ashley, then print me. And we need it to be in quotation marks because I want it to print out those characters and not an object. Yes, Sarah, do you have a question?
Can I do a comment in the middle of the for loop?
Yeah, you can put a comment wherever your heart desires, as long as there's nothing on that same line after that, but it can still be in the middle of a for loop. As long as your actual code does not turn green, you're good. Okay, so I'm saying if j is equal to Ashley, then I want it to print out me. So let's go ahead and just run that and see what we get. So we get it just printed me, but we don't really know, if it was correct. So what we want to put in is ahead of that, we're going to put up here, we'll say print j, so that way we know what we're printing out. So make sure that your print j is on the outside of your if statement and on the inside of your for loop. So it's going to say for j in names, so it's going to run through names and it's going to print Ashley, Caitlin, Colleen. So then we have this if statement that's saying if it's printing Ashley, then print me, because I want that to be an identifier. That's who I am. So I want R to recognize that. So let's say, okay, well, any questions so far? Yes, Caitlin. Did you put your print j on the inside of your for loop but the outside of your if statement? Okay, let me look. Okay. Right. Is it still what? Where? Oh, okay. I still spelled her name wrong, everybody. I never ran the... Her name is Caitlin. Her name is Caitlin, and I know that, and I know how it's spelled. Okay, so let me rerun all of this code. So this is a perfect example for A, make sure you run your code, and B, why we're working in the R script, because now instead of having to retype out everything I just did, I can just highlight all of this and run it. And now her name is spelled correctly. So, perfect example. Thank you for having a difficult name. Okay, so it is. It is. Everything's always her fault. So, okay, so if we want to now say Caitlin, her name, we're going to say sister. We want to, on the outside of that if statement, we're going to say else if. So the reason why we're not using a second if is we want it to, if this is true, so if it's Ashley, then we don't need to then go to the rest of the if statements. We can just, we're done here, move on. So we're going to say else if. So if the first if is not true, we want to check this other thing. So else if j equals Caitlin, which first of all make sure it's spelled right, and also we're using the double equals again because we're asking a question. Then we're going to print sister. So now if we run this code, it'll print Caitlin, sister. So it's checking if J is Ashley, yes. Okay, let me take a look. Okay, so you should use different lines so that it's easier because this if statement needs to be on its own.
Okay.
Just hit enter.
Here.
Yep.
Should I run this?
Yeah.
Okay.
Okay.
Thank you.
Yep. Okay, any other, yep. Yeah, so he was having the same issue. So if it's not on different lines, the if and else if, I think, gets a little bit messed up. I think you would need to have a semicolon in between, so which it should say if, and then at the end of that curly bracket put a semicolon. But
So it actually happened in just the first part before the else if you then, like it couldn't get it run when the actually goes to
R expects curly brace pairs to be on separate lines.
Okay.
I mean, you can make it work, but it's a lot easier to do.
yeah, just do it my way.
It's a lot easier to read if nothing else.
Yeah, it is, and it is easier to read and easier for you to go back and like look at it. It's easier to interpret. Yes. Okay. Okay. Yes.
Why does it print, so it goes, it sees Ashley, and then it prints me afterwards, rather than replacing Ashley with me?
Because I did not tell it to replace Ashley with me. I told it print me. So I'm just saying I want it to be printed out, and I told it to print Ashley. So I told it print J. So it prints J, and then I said print me. So we could ask it to replace Ashley with me, but that's not what I asked. I said, just strictly, I said print. So that's my answer. Does that answer your question? I'm not sure if I explained that.
And then my second question, what are the one that's in the square bracket? What is that referring to in the console?
Oh, this is, okay, so when you're running something with a lot of elements in a list, it's helpful because if you had, let's say, 25 fit here, and then it'll say 26 here. So if you wanted to see, like, okay, I want to look at the 100th person, it'll have, like, 1, 12, 24, and then you can, like, look and be like, okay, so I know that this first one is 100, so then I can go 101, 102, 103, that's the 103rd person. So it kind of is just like a helpful way for you to print out. So if you only have one element printing out, it'll always just have a 1.
Do you know what the Mac equivalent is of a controlled break?
No.
Okay, she's stuck in she had an uneven number of quotes. Double tap escape.
Oh, yeah. Okay, good. Thank you. Yes. Yeah, so basically it wants you to have your, like each like command that you're giving it has to be on separate lines. So I'm saying like do this, do that. You want those to be on separate lines.
Does the print have to be on a separate line?
No, the print does not have to be on a separate line.
Just the if and the for?
Yeah, the if, the for, if, and else if. But it is easier to read this way because if I wasn't just saying print and I was going to say do this and that and the other thing, you want those each to be on a separate line just so that it's easier for you to look at. Yes?
Alternate
Okay, and did you highlight the entire, you have the entire thing highlighted, and,
Control enter, it does whatever I have in there, it just goes back into.
he's going to come look at it for you. Okay, so we're going to add one more piece to this. So if you already did an if and an else if, or you can just do if and else. So we're going to add an else statement, which means it doesn't fit the first two criteria, anything that doesn't fit that. So else, and since we only have one other thing, the only other name left is Colleen, we can just say else instead of doing another else if it's Colleen. We can just say else, print, mom. So see how I have that all on the same line? That would work, or I could have it on a new line. That would work too. So both work. So make sure that, again, you have to highlight the entire thing and run it. Yes? Because we're not saying else some condition has to be the case. We're just saying else if everything above it, if those weren't the cases, then we want something to happen. So we don't have to specify else if something's the case. It's just else, yes.
So I've now fixed the same problem 3 times, so I want to talk a little bit about it.
Yeah, here, wait, can you, for those in the recording, might want to hear this as well.
Sure, and this happens in other programs too. Sometimes you have an unbalanced number of quotes. You have a quote somewhere that doesn't close. And so what will happen is you'll try to run something, and all you'll see is your syntax show up in the bottom part, but it doesn't run anything. The other way you know that you're stuck there is that there's a plus sign down there instead of a caret, or the greater than sign.
I call it a carrot, but it's not a carrot.
Sideways caret. Greater than sign. And so if you're ever in there, it means that you've run an odd number of quotes. To get out of that, if you have you can either hit Control Break, or I've now learned Escape twice works on all the machines. Okay?
Okay, great, thank you. Okay, so now we are gonna go over to the data set that, let me just give instructions real quick. So make sure that you download the data set that I sent to your emails this morning if you filled out the survey. If you didn't fill out the survey, ask a neighbor to send it to you. You what? Okay, yes.
I feel like I typed it incorrectly.
Else space, put a space in
So
there
there
and
has
see
to
if
be
that's
a
right.
space.
Oh, yeah, also you're missing a curly bracket at the end to close the for loop.
Up here? This isn't like that.
Okay, so you need to get rid of the bracket here. No, in the for, yep, there. Get rid of that and put it at the end. And that'll fix all of your woes will be gone. Oh, yeah. Okay, so this is a great question. What's the difference between a parenthesis and a curly bracket? A parenthesis is either you're just putting parentheses order of operations, or it has to do with a function. You're saying the function, so print is a function. Print is a function that says print it down here. But so in the function print, it requires your stuff to be in parentheses so that it knows what you're wanting to print and when you're done saying what you're printing. So if you didn't have those parentheses, it wouldn't work. And the curly brackets is specific to the for, the if, the else, and there are a few other things like dictionaries and things like that. But it's specific to that function, just as print has the parentheses that go with it, the curly brackets. And the reason why they do curly brackets is because if you have a lot of code, you get a lot of parentheses, and sometimes it gets really confusing how many parentheses you need. At the end of a line, you could need 3 or 4 parentheses. So they do the curly bracket just to make it different so that it's like clear in I am ending my else statement or I'm ending my for loop, just to help it make it a little bit easier.
So just because it's a specific function, that's why there's a parentheses after if, but a curly bracket after else?
Yes. Yeah, so if has the parentheses where it's saying if condition. So the condition is within the parentheses. So it's saying if something is true in the parentheses, curly bracket, then do whatever's in the curly bracket. So what's in the parentheses is the condition saying I want to know if this is true. If it is, then do whatever's in the curly bracket. Okay, so did everyone get the data set and have it downloaded? Okay, so I'm going to show you guys how to load that data set into R. So first what we want to do is just name our data set whatever we want. I always name my data set D, just because it's quick and easy. Data D. It is, yeah. So my data I always call D. So then we're going to use the function read.csv. So the file that I sent to you was a CSV, so we're going to read that file in. So now inside this read.csv, you have a couple options. You can either write out the entire path name of the file that you're doing, but I don't recommend that because you need to include like desktop, user, all of that stuff. So what I always use is a function called file.choose, and this will then pop up a browser window where you can click on the file that you want. No. So if I were to run this, it's going to pop open a window, and then I can go to my downloads and click on that file. So now you can see over here, it has D has 40 observations and 10 variables. So that's how we know that it read incorrectly.
Is that an issue when you go back to your code and you're trying to remember what data set you use?
Yeah. So yeah, so I do. So for some things, I do write out the whole path name, and there is a way to do that where it's a little bit easier. What I do is I put it in the same folder with the R project. So R has projects where it's like a workspace that you can have. So I save the file to the same workspace, and then you can type in get.wd, which tells you what's my current working directory. No period? Oh. So just get.wd. Okay, thank you. So get.wd, and then you can see this is where my current path is. So then I just copy and paste that in, and I know the name of the file, so I just put an extra slash and write it in. So that's my little trick around that. But if I'm doing something the first time or quickly, I'll just use the file.choose because it's a little bit easier to get to your.
Don't do it. It's so easy, but then you come back to it and you're like, oh, what did I choose last time?
Yeah. Yeah. So or if you want, you can put like a comment after it and say I have the responses file. That's one way. It probably, if you're gonna do something, it probably makes sense to write out the whole path name. But for our purposes, I think the file.choose function is fine. Yes.
And then you can also run file.choose in the console and then copy and paste the whole file afterwards.
Yeah. Mm-hmm. Yeah, that is another good option. Thank you. Yes.
So if you just wanted to use the file pathway, do you?
You put it in quotes. So just like how you see it down here, you would just have that instead of where it says file.choose, it would say this.
And one thing to note, R wants forward slashes, not backslashes. Every other program uses a backslash, but this one wants, where you see the forward slash users, forward slash Ashley. A lot of people get tripped up there. Use the forward slash to delineate the folders and subfolders.
Yes. Okay. Any other questions? Yes.
I was always, when I first learned R, I was told to go to session and then set the working directory.
Yeah, you can.
So why do you not, like, do you recommend one or the other, or?
I like to create my R projects in an existing folder. So you can, and I like to just then, everything's in that folder for that project. So for example, I created you a Heart Shiny App folder. And then everything for that is in there, including my R workspace. So that way, like, it's already set and I don't have to set my workspace. So when you would set your workspace is if you create the R project, then you want to put it in a folder later or put it in with something else or whatever, then you can change it. But I recommend just right off the bat, put it in a folder, like make the folder before you make the project. That's how I do it. Did I not answer your question?
Yeah, I guess I didn't realize I was misusing session. So setting the working directory. That's how I would set the folder with the project and put everything in there.
Okay.
But then you can call the data with just the file name because it's looking to where it is without the full file path.
Right. Yeah. So you can, if it's in the folder that you're working in, you can just put, you don't have to put the whole path name. But I also recommend not doing that because if you then, let's say I'm working here and I'm like, you know, I already did this in what I did for you. I'm going to now take it and use for Dr. Ganley. So I can pull up that file, but I'm not working in that workspace. So the files won't be there. So I want the whole path name so that I can take this file and use it in any project in case I need to not reinvent the wheel or do anything like that. So, any other questions? Yes.
So I successfully choose the file via that code on line 32, but it doesn't show up in my as a data frame.
In your global environment?
Yeah.
Okay. So one way to check too is everybody can run this is column names D. What that's saying is what are the column names in dataset D. So if you've successfully, you do? Okay, then it's in there. I don't know if you just can't see it over to the right or whatever, but if that worked, then you're good. So this is just telling us the column names. But as you can see, they're kind of long and not what we'd want our variable names to be. So we can easily change this to whatever we want them to be by just doing column names D and then equals, and then we can name it whatever we want. So again, we're going to use that C function because I'm going to list out multiple names. So I'm combining that into one thing called column names of D. So we're going to just name them shorter, so time, email, attend, and make sure that you're using quotes because again, we want it to be the string word. We want it to be those characters, not an object that we've previously called time. So experience. Oops, make sure you spell things right. Experience. Software. And you can name them whatever you want. I'd recommend naming them the way that I am so that when we are working later, you'll be able to just follow along with me. But you can name, they can be whatever you want them to be. Okay, num for favorite number, color, gender, years, and suggest. Okay, so I'm going to do not that because that's still not enough. Do it here so that you guys can see that if you're copying.
So if you want to change these in your CSV file,
Yep, you can do that too. Just
you have to rerun the
yeah, so you'd have to rerun the D equals piece. That would, because I can make a million changes in that file right now, but I didn't re-upload it to R, so R doesn't know that I made any of those changes. Because I can completely just delete that file, and it won't affect what I'm doing in R. So you have to re-update if you change anything in your file. Okay, so then we're going to run this piece, and then we can just double check and make sure that we did it correctly by just running column names D, and we can see that now my new column names are what I chose them to be.
Wait, so did you just run something in the console?
I did, yeah. I just ran column names D in the console because I didn't need that to, or you can just, we've already typed it here, Command Enter, and it'll show up again. Okay, any questions? Yeah.
So this isn't changing the actual CSV file?
No, this is changing the data frame in R called D. So we're changing the data frame within R, not in the file. That's a great question, yes. Yes, so if we wanted now a new file with the updates, you can use write.csv, which is a function that can then write a data frame to a CSV. So that's another option too. If you want to change things in here and then you for some reason want the Excel file, you can write it out as well. Yes, Krishnik. Oh, okay, Kim, did you have a question? No? Okay. Yes? No? Okay. So now let's talk about subsetting. So the easiest way to subset is to use square brackets. There's also a subset function that's literally called subset. So that's another option, but the quickest and simplest way is to use the curly bracket, or use the square bracket. So that's what we're gonna do. So we're just gonna say less, which is just a data frame that is gonna have less data. And we are going to say D and then square brackets. So this is saying I am subsetting data frame D. And then how in these square brackets it works is it's rows, comma, columns. So which rows do you want and which columns do you want? Rows, comma, columns. So I want to keep all of the rows. I'm going to have blank and then a comma. So it's just saying keep all of the rows. And then I'm going to take out, so I'm going to use a minus sign. So we're going to take out, and then we're going to do 1, 2, and 10. So we're going to take out columns 1, 2, and 10 and keep all of the rows because we're not telling it to do anything with the rows. We just want strictly do something with the columns. Yes. The C is combine. I'm telling you multiple values I want to combine into one thing. So if you were to just do 1, 2, 10 there, it wouldn't know whether you're saying I want row 1 and column 2 and 10, or I want row 1 and 2 and column 10, because it's already using this comma as part of this subset function. So the way that the C works is it's combining it into, I'm talking about the columns is all one thing. So C is combine it into one thing, I'm talking about one thing at this time. Okay, so if we run that, we can just take a quick look to see if the columns are what we want by just using the head function, head of less. What head does is it gives you the first 6 rows. So the reason why we're doing that is just to see are these columns what we want. So now as you can see, we've gotten rid of the first 2 and the last one. So where it said time, email, and suggest, those are now gone. So that is one way to do it with taking out. Now I'm going to show you a way to do it by selecting. So we can say same as less is what I'm going to call this data frame. And we're going to take it from D. And again, we want all of the rows. So we're going to keep nothing and comma. And then I'm going to say that I want 3 through 9. So I'm saying I want to, instead of getting rid of 1, 2, and 10, I'm going to keep 3 through 9. So then when we run that and do head of same as less, we get the same exact thing as what our last data set was. Yes, Caitlin. Yes, then yes. So that's why we had to use the C function earlier, is because, and we could also use the C function for this, but you'd have to write out 3, 4, 5. You'd have to like write them all out. Whereas that colon is really handy because it's saying everything in between there. So yes, good point. Yes, Kim. Yeah, hit escape twice. That work? No? Shots, can you help her? Okay. Okay, so now we're going to talk about if we want to select a specific, yes?
Sorry.
That's okay.
I'm stuck at call names. It's like I did escape to get carrots, but it's still not.
It's not giving you, okay. He'll come over and help you with that. Okay. Okay, so if we want to select a specific column, so if I want to just, instead of talking about the whole data frame, I want to talk about a specific column, what I can do is I can, so like let's say I wanted to take the mean of the number of years that people have been at FSU. So I would say mean, which is a function that takes the average, pretty standard. And then I can do $$ years. So what the $ does, it's saying I want to take this column within a data set. So I want data set D, $, meaning I want a certain column, and then the column name is years. So $$ years is going to give us all of the values that are in that column. So if we run that, we can see that the average number of years of people in this room have been at FSU is 3.05. Questions on that? And are we getting caught up over there? No? Yep. Yes.
Sorry, I kind of missed what the head function was.
Okay, the head function gives you the first 6 rows in your data set. So the reason why I use that instead of just typing in the whole data set is if you have a really long data set, it can't print everything out into the console. So if you have 4,000 rows, it's not going to print that out and it's going to cut off. And I didn't care to see all of my data. All I wanted was to really see if the column names were showing up correctly and if my data looked right. So usually I just use that as kind of a check to see, does it look right, basically? Yes.
Make a comment.
Yeah.
And so this is just a general comment. I've seen this pop up. Not all the time when you run something will you get something that appears in your console, right? So if everything runs correctly and you're calling it to an object, you won't get any output. This is a very...
But you should get, it should still print out what you wrote up top. So even if it doesn't print an output like this, you still should, unless you didn't run it. So that's the key to know whether you ran it or not, is if it showed up down here. But if I say D equals a certain file, it's just going to print that out. It's no news is good news, is what my professor used to tell me in high school.
Yeah, and so this is very different from SPSS and SAS and everything. When you run something, you'll get some output no matter what. In R, you may not, right? Especially if it's sending it to an object, you won't get a say, hey, this ran, or hey, this, no, it'll just appear. The code will appear down here, and then just your little sideways caret.
Okay, so you probably have...
You have a quote effect that's missing right there.
Oh, perfect. Already.
Yeah, I feel like we might be missing a couple quotes.
Yes.
Somehow they're catching up. Something I find SPSS users.
Hold on. for those watching at home, they may want to hear your comment.
Something that I found with working with people, our SPSS users, is they like to look at their data.
Literally, my next question was, how do I?
Yeah, and so do you want to show them what
Yeah.
the global environment
Sure.
is and how that works?
Sure.
Yeah.
Okay, so for those of you with trust issues, let's take a look. So, okay, this is your global environment over here, which is everything that you've ran in this R project. So you can clean this out using the RM function, or there's a little broom there if you wanted to, delete and start over. But you can either click on, so see here, I can double click and it'll show up here and kind of like let me look at what the data looks like, or you can just type in down here view D. So that's what, when you click, it'll actually just run this code for you, but you can just type that in as well. Yeah.
Small question, but how do I open it? It's not open on my RStudio, like the environment history.
Does it have this piece and you just have to, or it's not there at all? That? I know you can. I really don't. I'm not sure. I think it's under the view, but I haven't changed that in like years. You got it? But so, okay, so view, show environment. Thank you. But so even if you don't see it over here in your environment, you could just type this view D and make sure that it's a capital V. It's capital V in view. So that is if you wanted to look at your data. Thank you for that. I wasn't even thinking that.
Real coders are like, why would you look at your data?
Yeah, why would you want to look at it? Okay, so next let's talk about packages. So what are packages?
Oh, I listen up to this. This is recorded.
Okay, so packages are something, you can see over here you have this nice tab too. So packages are something that contain functions that are written by R users. So any R user can make a package with functions and submit it to the CRAN, which is the Comprehensive R Archive Network, which is where we download all of our packages from. So if you write a really handy function that works well for you, you might want to submit that so that other users can use it as well. So, yeah.
Wait, so what's the difference between a package and a function?
A function is within a package. So a package is like, contains multiple functions. So in a specific package, it might do a bunch of different functions, but for a similar thing. So it's just, once you have the package, you have all of those functions within that package. But you can also write functions that aren't in packages if you were to write it personally yourself, but then they're not available to all our users until you make a package and make them publicly available.
And the packages are peer reviewed, so like if it's actually on CRAN, there's a really good chance it should work. So you can also get them from like other sources, but get them from CRAN.
Yeah.
So this is literally the engine that runs our packages. People have written packages to run Novas, they've written packages to do HLM, all kinds of things, which could get confusing, right? Because like if you're, it's kind of like SPSS, where you can run an ANOVA using GLM function. Sorry.
Well, you can just keep this. Like, I feel like.
What are you saying, Ashley?
Saying you might be.
Say I talk too much, probably. And so functions and packages, right? So packages are available out on the CRAN. That stands for Comprehensive R Archive Network. And there's so many of them. And people write them, right? And so this is the freeware, open source kind of thing that R has, that is both a positive and a negative, right? So for example, if you're running an SPSS, there may be one or two procedures that you can use to do the same thing, right? So you can do an ANOVA in SPSS using the ANOVA function, using the UniANOVA function, using the GLM. But SPSS has complete control over how these functions are working, right? In R, it's sort of like the Wild West at times, where there may be 12 packages out there that all do ANOVA, and all do it slightly differently. And you just have to become sort of a savvy user to know which packages you want to use and which ones are good for you and which ones aren't.
That being said, most of the time when you are working with a function in a package, it has a help option. All of them have this help where you can look at what the specific features are. And they also, most of the time, you don't have to act like, oh, I need to, find the, there's multiple options. I need to make sure that I'm not using a bad one. Most of them are not, just because they're written by people, like he said, they are peer reviewed, so they should generally be right. But again, you don't want to just, any coding you're doing, you don't ever just take at face value. So if it doesn't look right, you might want to look into it. You can look at the source code for all of the functions to see how they actually made this function work. But we're not at that stage yet. So, okay, so let's, one of the first packages we're going to do is called Psych. So if you already have the package installed, you don't have to do this step, but if you haven't installed it yet, you'll do install.packages and then psych in quotes. So then when you run that, it should, say whatever, something about CRAN, downloading, should be in red. So run that. And then once you have it installed, you can have 1 million packages installed but not open. So in order to open and actually access it, we have to do the library function. So library psych will actually run this, and it'll say we're now opening this package, which is going to make these functions available to you. Okay, so does everybody get that far? I don't know if it takes a little bit to install and stuff. Yes, Allison.
Do you ever run into problems with packages being written under older versions of?
Yeah, so that's something that Schatz has brought up a few times. I have actually never had it. It does tell me that it was created for an older package, but if you have the newest version, I've never had it where it won't run if it's made in an older version. So most of the functions are back compatible, so just make sure that you have the newest version. It sounded like to you that you've had a couple packages where you have needed the older version, but I've never run into that.
I have. And so I've run into packages that were built under older versions, and they won't run under the newer versions. They won't be. And so the solution to this, and it's clunky, but the solution to this is you go under Tools. Can you click on Tools? Global Options. And then, click on R. Well, that's weird. In mine, I can select which version of R that I want to run. Okay, so if I click on Tools, Global Options, my first one says R version, and then you can click on Change. And so you can run, as long as you have that R version installed, you can run multiple versions of R to make your package happy. Oh, that didn't sound good. But, and the worst part is that oftentimes it doesn't tell you which version makes it happy. Right? So sometimes you got to install multiple previous versions. Now, hopefully you won't run into that, but there's some, as you get into more upper level stat stuff, some things are written just by one person and it was written in a particular time period and they use a particular version of R and you need to have that version of R installed. So you can have multiple versions of R installed. You still only have one RStudio. And then you can select the R version that works for you.
Kim?
When you typed in library site and read it, is it supposed to say all that? Right.
It doesn't have to. So the reason why it's telling me that is I already have a library open called ggplot2, which has a similar function to psych. So I'm actually going to show you that next, how to deal with that. But that's what it's just warning me, like that this function has the same, like, you know, so that you know not to mix them up. I'm going to show you that right now. Yeah, if that didn't show up, it means you don't have ggplot2, so no worries. Yes.
Mine didn't show the attaching package site.
But it ran, right? Then you're fine. So now we'll look at a function called describe. And we're going to describe D, which is our data set. And when we run that, it's going to give us some descriptives. So if you take a look here, it has a star after some of them, but not all of them. What the star is these are not numeric values. So email, you can't take an average of email. So it's like telling you this is a problem. So that's why this function is really great for numeric data, but not for any other kind of data. So you can see here experience, it gives you a lot of great stuff because it'll give you skewness and kurtosis and some other things, but not great for non-numeric data. So we're going to open up another package. So we'll do install.packages, and it's hmisc, capital HMISC. And then do library hmisc. Okay, so this is an example of where it's telling us a warning that this was built under a previous version, but it still runs fine, so not a big deal. Yes?
If it ends with a little caret in my console, does that mean everything's good?
You mean like down here you have a caret and like a new line?
Yeah,
Yep.
I don't get the same warning message.
That, like I said before, the warning message is just because I have other packages open. So for example, it's warning us right here, which is what we're going to talk about, that I already have package psych open, and it has a function called describe, and so does hmisc. So if I were to now just type in describe, it doesn't know if I want describe from psych or describe from hmisc. So I'm going to show you how we can tell it that right now. So we have to now, because we have a function from two different packages called the exact same thing, we have to tell it what we want. So the way that we're going to do that is we're going to say the package name. So hmisc is the package, and then you're going to use a double colon, which says I want the function describe within package hmisc. So that's going to tell you that, and then you can just do describe D, and it'll give you all of the descriptives from this. So for example, if we're looking at a non-numeric data like gender, it's going to give us frequency, proportion, things that are a little bit more tailored to that type of data, rather than in the last one, it kind of was just like star, I just don't know how to do this. So it'll kind of tailor it a little bit more to the type of data that you're working with. But if you have numeric data, the psych one is really great because it does give you more information. So it kind of has some trade-offs to which one you would want to use. Yes, Kim?
Just a heads up, it kind of takes a while.
Yeah, if you're still installing, I will give it a minute for you guys to install. Yes. Okay, let me come look. Yeah, the error messages aren't always super helpful.
Yeah, I don't know what any of this
Okay,
means.
let's see. Error object. Okay, so I don't know what this object is.
I don't know what it is either.
Did you try to call that somewhere?
No, all I did was this.
And it's not even
Right.
not export.
I also don't know. Oh, that's our language.
I don't know. You might know the errors better than me. I don't know what this. It's saying that she's calling this object, but she's not actually calling it. Like she's not trying to call that object. So why is it giving her that error? Okay. Is everybody caught up to this point? Is anyone not caught up to this point? Okay. Okay. Yeah.
I just one broad question. If you install a package, do you have to use library each time you
Yes. So the question is, when you install a package, how often do you have to do the library? And it's each session. So if I were to now shut down R and open it up, even though I'm in the same workspace, same everything, I still have to reopen that package. So what I always do is at the top of my code, I put library and all the packages that I'm going to use. Because I can type library as many times as I want. There's no, like, you don't have to close it to reopen it. So I can reopen it as many times as I want. So I usually just then, every time I run that code, I just highlight the whole thing, including where it says library, and run it, just so that I make sure that I have the library open. Kim? Right, because I opened Psych, I was using that as describe. Now, when I opened the new package, I have this new package that has the same function in it, so I have to tell it which one I want to use. So now if I wanted to continue on, I'd have to type in psych : describe, so that I know that I'm using the correct package. Okay, is everybody good to keep going? Yes, question? Yes, so that was a great question. So guys, can you listen up? So that was a great question was, can you just click over here in the side? And yes, you can. You don't have to type library. I could just click this little checkbox, and that'll do the same thing as library, and it'll actually, if I click that, it'll write out library for me. So that's just one of the user interface versus code things. I like to do it in my code because that way I know when I look back at the code, I know, okay, I need to use this specific package. But if you are, not a very code person and you really like to use as many clicks as you can, then that would be a great option for you also. And you can also install packages that way. So instead of doing install.packages, you can click here, this install, and then type in the package name that you want, and then hit install. So that's one other option. And one of the reasons sometimes I do it there is if it's either like a longer thing and I want to make sure I'm spelling it right. If I start to type something in here, it'll like give me options so that I can make sure that I'm like actually typing the right thing in. Because as we could all see earlier with me typing Caitlin, my sister's name that I've probably typed a million times, I can make mistakes. So I often will do it there. That way it'll give me it'll finish it for me. Yes, Sarah.
Is there anything wrong with, or I guess, will it backfire on me later if I use this, like the interface, and then copy and paste the code into...
Nope, you can do that. You can do that too. So you can just use the checkboxes and then copy and paste that so that you can run that later. That is also another option. Okay, so let's look at another couple of handy functions when you're dealing with data. So one function is called nrow. So what nrow does is it tells you the number of rows that you have in your data set. So this is helpful if you want to get your sample size or different things like that. Nrow works really well if each of your rows is a participant. So that works well. And then you can do the same thing with columns. Just ncol of D is just the number of columns. So that tells us that we have 10 columns in our data set. So nrow only works for a data frame. It does not work on a vector. So if we wanted to know the number of elements in a vector or in a list, then we would use the length function, length of D dollar, and then let's just say attend as one of the ones, so we get 40. So 40 people answered, are they attending or not question, and that gives us the same as nrow. So length is what you would use for the number of elements in a list or vector, and nrow is the number of rows in a data frame. Sarah, did you have a question?
I was just like, is there one that could just work regardless if it's a list, vector, or data frame? Like, is there...
Length should work for all of them. So if you use length on a data frame, it's going to give you like the length, number of observations, right?
Yeah, but if you, yeah, so you can just use length. I like to do nrow because it's like the name is intuitive, the number of rows, nrow, and it's shorter and easier for me to do. But that, I mean, again, that's a personal preference thing. So nrow works for data frame. I think, does it work for a matrix too? It does, yeah, it works for matrix too. But in our purposes, data frame. Okay. No, because it's going to have an NA in that value. So if you were to ask it to print out, it would literally print out NA as like the letters. It would print NA. So it still has a value, even though it doesn't have a value. Does that make sense? Its value is missing.
Is there a way to find out?
Yes. So we are going to get to that later. But you can use is NA as a function or NA.omit as a function also. We're gonna get to that in just a little bit. Okay, so any other questions that we have gone over so far? Yes?
Could you just do a quick review of when to use parentheses, when to use square brackets, and when to use squiggles?
Yes. So parentheses are if we're using a function or if we are using like order of operations in math and you want to like say do all this first, then add 10. So that's when we would use parentheses. If we want to use square brackets is for subsetting or lists and dictionaries. So we didn't talk about lists yet. So in our what we've done so far, it's just for subsetting. So if we wanted to use square brackets, you'd say D square brackets, and then you're saying I want to subset data set D. And the curly brackets are a part of the for loop, if statement, and else statement in that the parenthesis is, so if you're saying if, and then inside the parentheses is condition, so what is this true? And then the curly brackets is then do this. So inside the curly brackets, you're telling it do this. Inside the parentheses, you're asking, is this the case? Does that clear that up for you? Okay, great. Okay, so next we're going to take a little bit of a look at some of our data. So a handy function to use when we're working with nominal data is the unique function. So unique, and then we'll look at $color. So again, the $sign is saying the column. So I want data set D and then the column colors within data set D. So as you can see here, if we're looking at this data, you can see that the unique value, because I had a type in, we can see that big P purple is treated as different than this little p purple. So we can go ahead and change that. You can change anybody's response in the data. So we can go ahead and change that so that big P purple is little p purple. So one way to do that, there's multiple ways to change your data, but the easiest way that I believe is by just saying D dollar color. So we're saying within this list of D dollar color, we're going to check within that, that's what the square brackets is within, to see if D dollar color equals, so we're asking a question, is it equal to? And then we need to use quotations around purple because we're saying the character string purple, not an object. So don't forget those quotes around that. So we're saying what this says so far is if within D dollar color, if D dollar color is purple, then we're gonna do something, and what we're gonna do is reset that to be little purple. So what this is basically doing is it's replacing big purple with little purple, but it's saying within D dollar color, so it knows where we're trying to look. So we can go ahead and run that, and then if we rerun unique D dollar color, you can see that there's no longer a big purple. It's just little purple. So there's some other ones. We don't have to do it for all of them, but one thing I wanted to show you is you can copy and paste your code and just copy and paste it and then change just a piece of it. So we can just change this to be green and green. And blue and blue. So we'll just run that. There's some others too, but for our purposes, we don't need to change all of the values. But if you, obviously this is one of the reasons when you're choosing how to get your data. If you have specific ones that you know are popular, so for example, like blue is a popular favorite color, so you would have probably want to do like select boxes, and then you can have an other. That way, if everyone who does fit that blue description can just click that, so that's an example of setting up your data before you even get to the analysis process. Okay. Any questions on how I just replaced those values? Yeah.
You don't want to do it line by line because it's too lower function?
Oh, that's what I was going to ask. It's already just turn them all lower.
Yes. Yeah. But I wanted to show you, so one of the reasons why I wanted to show it this way is sometimes people put in values like -99 or whatever for their missing data. So they actually need to replace an actual value. Or if there was a data entry error and somebody's birth year says 3005 when it really should be 2005. You can go in and like change it that way. So that's why I didn't want to do it that way. But yes, you can use the lower function so that it'll just make it lower. So if I wanted everybody who did purple to be NA, I can just type in NA as the value there. Don't actually do that because we want there to be data there. But I'm just showing you as an example. You can just type NA, and then that's the missing data, what R treats as missing data. Okay, so let's see what we got next. Okay, so another way that you can look at your data is using table. So table is a function that will give you the frequencies of each of those responses. So you can see that 5 people said blue, and now that big blue has 0 because we moved who was in the big blue over to little blue. And green has 10 people, so it's just giving you the frequencies there. And we can use the bar plot function just around what we just did. So bar plot table D dollar color, and run that. And it should give us this was happening earlier too. It's like really small on the display, but you should see it on your screen. It should give you just like frequency table of which, so this is green, has 10. Does anyone have, here, let me show you that code again. Does anyone have trouble getting that? Bar plot, table, D dollar color. Yes. Yeah, so that, we'd have to change the levels. So levels is saying like the levels within a factor, so we'd have to go in and change what's in the levels. So what the unique is telling us is what are the unique levels that exist, but you can have, so for example, in data like yours, you would say, like you have options that are their education level. So you can have an option that says graduated from graduate school, but nobody in your responses had that, and you still want that to be on your table. That's why it doesn't automatically get rid of it, even though it doesn't exist, but you can get rid of it by changing, it's called levels is the function. Carl. Let her try to help you, and you got it? Okay. Allison, did you have a question?
If we just attach D, we don't have to do the dollar.
Yes, so if you do attach D, then you can just call color, and it'll know that you are trying to do in D. I highly do not recommend that. That is one of the things in R that it is nice if you have a really long name of a data set, but I don't recommend it because, one, you could have a object called color, and now it's going to be calling the column in your data frame. And two, if you don't detach, that can cause trouble. And yeah, so I don't recommend that. You can, but I think if you have a long data set name, I always just, at the top of my data, I say D equals long data set name, and then I can just call D the rest of the time. So that saves me from running into some issues with the attaching. But yes, that is an option. Yes?
So I see that some people said cerulean and some people said cerulean blue. That's the same color. So if I want to recode cerulean blue into cerulean,
Yep. You would do the same thing we just did. So it would say cerulean blue in here, and then cerulean out here. So it's whatever. What'd you say?
even though that's an existing name for the
Yes, yeah, because what it's doing is it's saying, so within this piece, it's saying find the rows where this is true, where color is equal to blue. So find those rows. And then set those rows equal to little blue. But it doesn't affect the ones that were already little blue, because we're not saying find the ones that are little blue. So it'll only, that's what this first piece is, it's finding the ones that you're talking about. So it won't affect the ones that are already there. There are times where you'll run into an issue where if you're trying to set something that's not already a value, you can run into issues with that if you already played with the factor levels. But that shouldn't be a problem in most cases. But just know that could come up if you are trying to set something that doesn't exist. It can give you an error message in certain cases.
And so what is cerulean blue? It's the most amazing blues?
Yeah. It's one I always get.
Okay, so we're going to do a little bit more with subsetting of data where we're using conditional subsetting. So what I want to take a look at is people who responded to the survey who have experience less than or equal to 5. So I'm going to call that group newbies. And we're going to take from dataset D, and we're going to use those square brackets because we're subsetting dataset D. And then we're going to say we want to keep all of the rows, or not all of the rows, we want all of the columns. So sometimes you put in the comma and then move over, or you can put the comma at the end. Your choice, but a lot of times people forget to put the comma in. So either put it first or double check, make sure you put the comma because you'll get an error. So we're going to say where $experience is less than or equal to 5. And then we run that, and if we wanted to see how many were in that group, we can do nrow of newbies. And you can see that 39 out of the 40 people put that their experience with R is less than 5. Great, because this is an R class for newbies. So that's a great response there. So then, again, we can, if we wanted to look within those newbies and we wanted to see just certain characteristics of certain people. So you can say, okay, I want to look at people who have been here for, a certain number of years, and I want to look at the software they use or whatever. So we're going to use this newbies. So we want to see the people who have experience less than 5. I want to see what software did they use if they're not using R. So I'm going to use that table function again, and I'm going to say newbies and then their software, because I want to know what software are those newbies using. So then you can see here it shows that 2 people are using Excel, 5 other, and 31 SPSS users. So it seems like the majority of you guys are familiar with SPSS. But R is better, so that's why you're here. Okay. So again, we can do the same thing with any of the columns, and we can do it where it's, instead of selecting what is the case, we can select what is not the case. So I want to look who in here does not like blue. So I'm going to say non-blue lovers is equal to dataset D, and we want the rows in which $color does not equal. So does not equal, you use an exclamation point and an equal sign. So when we were using double equals to say, is this equal to each other? This is now saying, is this not equal to each other? So it does not equal, and then we'll type blue. Oops, so this is an example of why you always put the comma in. So this is, when you're subsetting, it's rows, comma, columns. If you don't have a comma, it's like, I don't know whether you're talking about rows or columns. So it'll just give you an error message. So make sure you put your comma in.
Column means rows?
It's rows, comma, columns. So it's whatever's before the comma is we're talking about rows. Whatever's after the comma is we're talking about columns. Okay, so then if we wanted to see how many people don't love blue, then we would just type in this nrow non-blue lovers, and we'd see 35 people said that their favorite color was not blue. Questions on that? Yes?
What if you wanted to add the cerulean blue into that?
Then you can either change cerulean blue to be with the blue group, or you can create a new, which is what I suggest. I suggest not changing the original data. I suggest creating a new column that's like, new colors or whatever, and then changing that from cerulean blue to be blue. And I'll show you how to create a new column pretty soon. Yeah.
Have you budgeted a bathroom break for me?
Yeah, we can do that now. This would be a good time to. Yeah, no, we can do that
How
now.
long do they have?
I don't know, 5 to 10 minutes.
You gotta be specific.
Okay, 5 minutes.
Trust me.
Okay. So we can go ahead and get started again. So next, what we're going to do, yes? Yeah, so the reason why the formatting changes is based on how big your console window is. So if I were to do that and change it, then the formatting gets all weird. So you can just like make your console bigger and it should resolve that issue. And I think the reason why the table in some of them is weird is if you have a really long name. So when we were looking at the software, the other name was like super long. So it then like needs room to write that all on one line. So it like makes it weird. But okay, so if we're going to create a new column, we can just make a new column by saying $, whatever we want the column to be. So we'll call it new col. So $, new col, and then we'll make that equal to $, experience plus $, years. So that's just an example of how you can make a new column. And then if we were to look at column names of D, you can see now we have new col as one of the column names. So that's, to make a new column, you can just literally do $, new column. Okay, so then one of the ways to deal with missing data, a lot of people ask about, how do I get rid of all of the rows that have any missing data in it? So I only want to use complete data. How do I deal? Yeah.
I hit a snag, I'm sorry. I was messing around with the for loop,
Okay.
and then I got a bunch of plus signs on the console.
Yeah, so that's where you hit escape, escape, and it should get you out of that. Okay. So yeah, so you just want to keep your complete data. We can use a function called na.omit. So we'll just say D1 equals na.omit D. So what that's going to do is wherever there is an na anywhere in this data set, it's going to take out that entire row. So if we run that and then we look at n row of D1, that should not be the case. There should be missing data in the suggestion stuff, I think. Okay, well, if there was missing, yeah.
I might have missed this. Why are we using D1?
D1 is na.omit of D. So it's taking out any rows. Yeah, it's a new data set that's taking out any rows that have missing data in data set D. So I don't know why that's telling me that there's still 40 rows, but you did? Oh, okay. Did everybody get 37? You got 42? Okay, then I must have did something.
If you were talking about suggest, the blank is considered a character.
Oh, it doesn't say NA, it has a blank? Oh, okay, so that's the problem. So we didn't tell it what our missing data character is. So if you put -99 or you put a 0 or whatever you have for your missing data characteristics, in this case it's just a space. So it's treating that space as it's a character. So what we would want to do in that case is do what we did earlier with $, suggest, and we want to change where $, suggest is equal to a space, then we'll make that equal to NA. So if we run that, and then we run these things, it should work. It's just one space, right? Oh, it's just blank, not a space. Okay. Yeah, okay, now I got 16. There's no space in between the quotes. It's just quotes next to each other, nothing, empty. So if we change that to be an A first, and then I can move this down here if you're copying and didn't see that I switched to that. So if we replace our values with NA, and then we do the NA omit, then 16 people basically put something for suggest, is how that looks. Okay? Any questions on, yeah?
Does it matter that I use calculus, but
Yeah, so NA here is, we're saying missing, it's a missing value, not, it doesn't exist. This is a part of function. The function is called lowercase na.omit. That's what the function is called. So another way that you can look at that is using not is NA. So is NA is a function that, but that doesn't, you wouldn't use that on an entire data frame. You'd use that on a specific value. Okay, so let's talk about flipping data sets. So certain functions need to be in either long or wide format. So let's talk about how to do that. So in order to do that, we're going to use a data set that comes with R. So R has a lot of different data sets that are installed in R. So to open a data set, we're going to use the function data. And then the data set that we're going to use is called air quality. So you're going to use data and then air quality. And we run that, then it shows up, if I spell air quality correctly.
So, sorry, just to be clear,
I spelled quality wrong. Okay, yeah.
So this, for instance, if we had an SPSS data set and we wanted to switch it to a...
No, this is, R has data sets that are just publicly available data sets that you can use to do teaching examples and stuff like that. So I'm just pulling one of their already done up things. So this is not how you would if you had an SPSS file to convert it to R.
But SPSS files are usually in wide format, right?
Oh, I see what you're saying. This is the flipping the data set is how you would take it from that to use it in, yes, yeah, that's what we're gonna talk about now. But so this first data quality is just, air quality is just, this is just the data set that we're going to be using. So then if we wanted to just take a look at that, we'll just do head of air quality to see what that looks like. And you can see this will give us the first 6 rows. You can see that there are different columns for each of these different air quality measures. So this is in wide format, and we're going to talk about how to put it into long. Yes, Carl?
How do you know when you have to use, like what functions you have to use quotes for, and which ones you don't?
So the ones that you have to use quotes for is if you're installing a package or you're pulling data from somewhere. It does that, I believe, and don't quote me on this, but I believe it does that so that you can, if you have like a list of packages that you want to install, you can put that in an object and then like call that and it'll install multiple at the same time. So it does the quotes so that you are like, you're calling that as a, I don't know why it does quotes, yeah.
Isn't this data set in long format?
No.
It's not.
No, it's in wide because these are all like certain, it's just an example of, we're going to take it so where these are all in, like this is one person, and it's not a person, it's month and day. So at one day, it had all of these characteristics. We're going to turn it so that you have the day, and then it tells you you have like ozone, solar. I'll show you, and then I'll explain how it. Okay. So let's first we're going to need a package called Reshape2. So we're going to do install.packages Reshape2. And then library Reshape2. Okay. Has everybody got that installed? I'm not really sure how long it takes, so I don't want to give you guys time to do that. Okay, so we're going to create a new data set. I'm going to call it long, and we're going to use the function melt, which takes data from wide format and turns it into long. So it melts it down into long. I don't know why it's called melt, but so then in this melt function, it has different different things that you have to tell it. So first, we have to tell it what is the data set that we're trying to melt down, and that is called air quality. Oops, not air miles, air quality. And then next, we have to tell it the ID vars. So that's telling it what are the variables that identify what is the same about this group. So most of the time, you're going to use your participant ID or something of that nature. But I chose this one because it's not a participant ID, and it has 2 columns. So you need to know the month and the day in order to know like this particular ID of this, what you're looking at. So we're going to use both month and day. I think and they're both capitalized. So it takes both month and day to identify this measurement time so what we would consider our ID var. Okay, so run that, and then we can take a look at what long looks like. And you can see that now it's showing ozone. And when I was practicing this, someone had asked me, well, why does it say just ozone? That's only because we're looking at the first 6. So if we were to just look at what long looks like itself, you can see that it does ozone for a while and then switches over to solar. So it puts all of the variables into this one column. And so if you were using this for your data, it would be probably like condition. So what condition are they in? They're in, condition where they're seeing 1 picture, then they're seeing 3 pictures. So it's the condition that they're in would be there. So let's say that we already have it in long and we want to turn it into wide. We can do wide equals dcast. Dcast is the function that takes data from long to wide format. So we're going to use our data long that we just made, and we're going to cast it out. So we have to give it a formula of how to make this new data. So right now, it doesn't, if we were to just run that, it doesn't know which of these is the ID variable. So for all they know, ozone is the name of our participant, and that's what identifies them. So we have to tell it that month and day is what is our identifier. So we're going to say month plus day, predicted by. So this little squiggle, the tilde, is predicted by. So that's if you're doing an ANOVA regression or something, you put that in there. I like to think of it as predicted by is how I term that, but it's just you're predicting those. So then we're going to say variable because we want to use variable to use with this, and then we're not going to put value in, and value is what's going to be in our box. So if we were to run this and take a look at what this wide looks like, you can see now that it has month and day, and then all of these are casted back out. So these were previously variable, and then these were previously the values. So those, since we didn't include that, it gets put into that box. Okay, questions on the flipping data set stuff?
So this is useful because some packages want the data in long format, other packages want it wide format. So being able to do this is important as you become an R user because of what I just said.
Yep.
Okay, so the ID variable is kind of like your independent variable?
No, the ID variable is your participant ID. So in this case, I chose to use this because it has 2 columns. I wanted to show that if you had group and participant number. Let's say in your data you have it coded so that you have group A, group B, and group C, and there's 1 through 10 in A, in B, and in C. If you were to just say participant number, you'd have a 1, a 1, and a 1. But you also need to tell it that I have A, B, and C. So you would need those 2 columns to say participant group A and participant 1, group B and participant 1, separate people. So that's why I did it that way. But in most cases, it'll be participant number, something of that nature, subject number. Yeah, so it's what identifies, what makes each row different from each other. So it's the cases, the case variable, the ID that tells you what case we're looking at. So in this case, it's month 5, day 1, month 5, day 2. Month 5, day 1 is different than month 5, day 2. But if we were to, you just say day is our identifier, then day 1 in month 5 would be treated as the same as day 1 in month 6. So that's why you need both of those columns in this case. Yeah.
So, are you going to do an example of like cross design?
Yeah, so this would be kind of that example. It just would be you would only have, you wouldn't have this. It would just say subject number here, and you would just have 1 column, and then instead of up in here for where you're putting the ID variables, you just put subject number.
Okay, but as an example, so like when I've done long format before, I'll have them in, say within subjects variable.
Right.
So I'll have subject number, but then I'll have easy color, hard word, or something like that. And so then there will be a column. So there will be some each file will have both.
Yeah. So you would have 2 instead of it saying variable, you would have 2 variable columns. So you would have a color and a easy hard column. That then those 2 are the variables that then makes that a so let's say you're doing
Column and a day column.
yeah, so you're just
That's an example of
but instead of it being your ID variables, it would be your measurement variables. And you can actually in this function, you can actually there's I think it's MEA, yeah, it's measure vars, and then that's where you would instead of having 1, because if we leave it blank, we assume that everything else is the variable. So if you wanted to have 2 or whatever, you can put it in there. But if you don't have anything in there, it just assumes everything else is in your data set is what you're trying to melt. But let's say you have a really big data set and you don't want to subset it, you can tell it, here's what I want the specific pieces to be.
Okay, so there's a measurement variables thing.
Yes.
And so if you had a cross design where subject 1 would have each row be easy.
Yeah, so you would have,
hard word, and then my DB.
yeah, so your participant would show up multiple times. So you'd see, participant 1 in easy condition, participant 1 in hard condition, and participant 1 in easy and color blue. And so it would like split it up that way. So you would see participant 1 a bunch of times, and then it would participant 2, and it would be in long format that way. Okay? Any other questions? Yes.
Can you give a quick rundown on the Y function of a month plus day variable? What that is saying?
This piece?
Yes.
This is saying that your ID variables are month and day. So it's saying that both of those together is what's identifying those cases. So
Every unique combination
Yes.
becomes a row.
Right.
Is there a reason why we don't use ID bars there?
Because we're using a different function. So the melt function has a piece in it. So here, let's come over here and let's look at the help function. So if we were to look at melt and run it, so if we, doesn't even tell us, let's see. Let me do decast. There's too many things that are called the same. I have too many packages is the problem. But so basically,
Under the cast, decaf is specific. It was there.
it was there?
So down a little more. Down to appreciate their cast. Appreciate cast.
Oh, right here. Okay. So you can see decast here. It tells you what it wants in that function. So it wants data and a formula and some other things that we didn't need to include in this piece. But in the melt function, it wants something specifically called ID vars. So it just has to do with how the person writ that function to what it wants to include. So it's just specific to the function, not to, I don't know. So that's just what it wants. You have to give it what it wants. Any other questions about that? Okay. So let's talk about combining data. So if we had, let's first cut the data before we can combine it. So we're going to say first cols, which is just the first columns of data set D, and we're just going to take, so it's rows, comma, columns, remember, so we're just going to take 1 through 5, and now that's a new data frame with just those columns. And then we'll do last cols equals, and then we'll do 6 through 10. Oops, we need 6 through 10, not 5 through 10. Okay, so what we just did there is that's just taking the first columns are in one part of the one data set and the last columns are in a different data set. So let's say you have different data that are in 2 different files for some reason. You can easily combine them by saying all cols are equal to, and then we're going to use a function called cbind, which is we're binding columns together. So cbind, and then do first cols, comma, last cols, and then run that. And now you can see over here we have 10 variables again. Over in the environment, you can see it in my all cols. It shows that I have 10 variables, so 10 columns. So that cbind function is helpful if you have, yes?
So if I'm using that C1 function to put those together, I need to have done something to make sure that these are in an order that lines up.
Yes, so they have to be the same number of rows and in the same order. And I'm going to get to when they're not soon. But if they are in the same order, this is the easiest way to just throw those together. And you can do the same thing with if you have the same columns in the same order, but different rows. So if we did first rows, and then we'll do 1 to 20 because there's 40 rows, and run that. And then last rows is equal to 21 through, and then I could write 40, or I could do n row of D is another, because the answer to that is 40. So you can use a function within that function there as well. So if we run that, and then for combining rows, if we had half of our participants were in one data set and half of them were in another, we can combine that as long as our columns match up by doing all rows is equal to rbind, which is similar to cbind but for rows. So we're going to do rbind, and we need first rows and last rows. And then we run that, and you see we're back to 40 again. So that's an easy way to do that. But let's say you have a different number of rows and different columns, and you have some rows that are missing. So you have, only, let's say, a few of your participants completed the second piece to a project or something, and others didn't. You can combine data sets using the merge function. So before we do that, we need to make data that we can merge back together. So we'll just pull from this, we're going to make something called some other data. So this is just other data that does not match what we have. So we're going to take D, and we'll do row 1. We'll do row 1, 3, and 5, and we'll do columns is 2, 4, and 9. So if we run that, now we just have a data set that only has 3 people in it, and it has 3 rows in it. So we can use this merge function, so we'll say merged for merge data and merge. So why wouldn't we always use this merge function? Why would we not just always use this if it can deal with not having matched up data? Merge gets rid of if you don't have the participant ID, or if it doesn't, if your participant ID is not in both data sets, it will drop it. So it drops everything that it doesn't have this byline. So let me show you really quick. It only keeps what's in both. So we want to merge this some other data with first rows or columns, first column, first cols, and then we're going to use this by. So by is this function here, by, and then I chose to use email because email in our case for our data was like our participant ID. You only put your email, there's only one per respondent. So by equals email. So then when we run that, we have this new data set called merged, and if we click on that, it only has 7 observations. So it combined this data to be the participants that we selected and the columns that were in the first cols. So it only kept the data that had participant IDs in both. So it only kept the rows 1, 3, and 5 because those were the participant IDs that we had. So we're saying by is email, so it has to be in both. You have to have email in both in order for it to merge. Yes?
I got an error that it didn't recognize. Oh, never mind, spelling mistake.
Okay.
Yeah.
Okay, so this is helpful and is not helpful in certain terms. So for example, I was just working with some data that had a particular ID variable for people who participated in this second part survey to what they were doing. So I was able to use this merge function and I use this second ID variable to merge it by, and then it only keeps what has that participant ID variable. But when it isn't helpful is if you want to keep the data for everybody who is in both then this function doesn't work well for that. So then you wouldn't want to use this. Okay.
Use instead.
It has options for doing all of them. So there's an
Oh, you can keep everything
all
too?
argument. So like, if you've done other languages, there's like inner join, outer join, or whatever. So by default, I believe it's an inner join. So only things
Keeps
that
what's in
match
both.
all. But under the help, there's like all X or all Y, where you can choose like I want everything
Oh.
from whatever. So
You learn something new every day. So yeah, that's why that help function is really nice, because it tells you the different options. So apparently you can get it to keep everything within this function as well. So that's good to know. Thank you.
copy those values like over and over and over again to fill out so you have a square data frame.
Okay. So it'll just fill it in. Okay. So that's good to know. Okay, so let's talk quickly about how to do an ANOVA. And one of the things that I don't like about R, which you won't hear me say very often. R uses the AOV function. So we'll say AOV1 equals AOV, and then we'll tell it what variables we want. So I forget what I did. Experience and gender. So we'll just do experience. And then we'll use that predicted by symbol again. So experience predicted by gender, and then comma, the data set that we're using, which is D. So if we run that and then do summary AOV1, summary is a function that if you have a model, it'll give you the summary of that, basically the output. So if you just run AOV, it won't give you the actual results. But if you run summary, then it gives you the results from that. So if you're doing a regression or an ANOVA or anything like that, you have to use this summary function.
I'm just going to squeeze in here for a second. So this is very different from how SPSS thinks, right, or SAS, where you run something, run an analysis, and then you just get reams of output. And then you go through the output and you're looking for something that you want, right? This is the exact opposite. You run this AOV function, send it to this object called AOV1, you don't get anything. You're like, where's my output? It creates an object. You then have to go and query that object, right? You have to say, well, I want a summary of it. There are different things that you can do to an object to get the information out. And that's very different from how SPSS thinks. SPSS gives you everything, and then you have to go dig through the output. Here, R gives you nothing.
And then you have to ask.
And you have to ask for it. Thank you, sir. May I have another?
Okay, so let's do AOV2 equals AOV experience predicted by gender and attend. So gender plus attend. And then again, that's from dataset D. So we'll run that. So here is my little pet peeve with R. Its default is type 1 sum of squares, which those of you who have taken Shots and Novas class is not the ideal scenario. So if you were to just run this summary function, or this, you can also use lowercase ANOVA, AOV2, and these are both giving you type 1. So not great. So you have to use a package in order to get type 3 or type 2 sum of squares. So we're going to use package car. So go ahead and do that install.packages. And then car. And library car. And this is another example of where it's giving us this warning of you already have package called psych open, and it has this function that is also in the car package. So it just gives you that warning. So not always when you see red, you don't have to panic. It's just letting us know. Okay, so yeah.
If it's masked and you don't specify which package, does it always go to the most recent?
No, Does it? Yeah, I just know I always like to tell it specifically because I don't want to then be working in the other one and then go back and run my code and it's different. So if you're working with something that you know has two things that you like commonly use, I like to do that double colon just to make sure. But I don't like to take risks, so if you're a little bit more risky, feel free to just try it. Okay, so once we have installed that car package, we can use the ANOVA function in there. So it's capital A, ANOVA, and then we can just use that AOV2 that we already created. And then it's type, is it type? Yeah, and then type equals 3. So this will now give us the type 3 sum of squares. So that is, I don't like that the default is type 1. So that, you won't hear me say often that I don't like things in R, but so that's the one thing that I really don't like. But so this is an easy fix. You can just type in type 2 if you're looking for the type 2 sum of squares. So did everybody get to there? Any questions on that? Yeah, Sarah.
I was just, knowing me, I'll probably accidentally forget about type 1 or 2 or 3.
Oh, I've done that. It's not, yeah. You just, I think it probably, like, if you know that you're, doing an ANOVA and you know that, especially since you're like just learning R now, if you like just right off the bat know that, so sometimes I'll be like, oh, AOV, that's what I'm doing, and then just do summary, and that's like not the right thing. So if you're starting now and you know that could be a potential issue, and I'm warning you ahead of time, just try to remember that you want to use this capital A ANOVA function to get type 3 or type 2. Yes?
Do you have to use the AOV function first to make the formula?
Yes. You could put the AOV, so instead of putting AOV2, I could put this whole AOV function thing inside there, but then you can't reuse it and it gets messy, so I suggest doing it ahead of time and putting it up there. Any other questions? Okay, so let's talk about how to do a regression real quick. So we'll say mod, so that's just model. I'm calling it, you can call it whatever you want. LM, and then the formula that we want to look at. So I want to predict experience from years and favorite number. Experience predicted by years plus num, and then comma D, because that's the data set that we're using. It's data set D. And then again, you don't get any output there because you're just, it doesn't tell you anything until you ask. So summary mod, and then it gives you the regression output. Okay, questions on that? Carl? Oh, really? You need what? Oh, okay. Yeah, I can pause for a little bit if you guys are still trying to get that installed. But the nice thing is once you have it installed, it's installed, and you don't have to ever install that again. So you'll just have to do the library function.
So while you're waiting, you probably already said this, but experience predicted by years plus num, is that like a GLM with experience?
Yeah, so it's just a linear model with experience as the outcome and years and favorite number are the predictor values. Yeah, so either way, you have to remember to use a different function, not their, you can't just summary, whatever, yeah.
So will that give, so I don't know if this is what Kyle just said, but will that give you the interaction terms?
This is a regression. Above that is ANOVA, and yes, it will.
Okay.
So the ANOVA will give you. No, I didn't, because you're talking, yeah. So for up here, if you wanted to include the interaction terms, you would just do like gender times. You would use the star, gender times attend, or you can do colon.
Gender plus attend plus gender times attend.
Yes.
Okay.
Yeah. And then if you're doing a between subjects design, you also have to, or a within subjects design, you have to include the error term. So you do plus, and then it's a big E error. So again, I'm just giving you like a quick ANOVA. Here's the function, but there are more specifics. Like if you're doing different types of designs and things, you will have to include different things. Okay. Okay, so the last thing that I have to talk to you guys about is graphing. So I'm going to just do a really quick little graphing thing, but you could literally spend an entire semester learning how to graph in R. So I am hoping to do another one of these sessions that is specifically for data visualization. So I'm just going to give you a little taste of it today, but know that there's a lot more that you can do out there, and you can change everything on a graph that you want to. So the major package is called ggplot2. So go ahead and install and open that package. So if you haven't installed it, you need to install .packages again. Yeah.
Do we need CAR going forward right now?
No. Mm-mm. So if that's still giving you trouble, you can skip that. Yeah, I don't know what that means, but I would assume because both CAR and ggplot have like a lot of functions in them, so I wonder if maybe that's why it's taking a little bit longer, because they're like very.
Yeah, just like stuff.
Oh, it's not even.
It's happened like 4 times now.
I don't know what that is. Maybe there's an issue with something. Yeah, Carl.
For installing this ggplot2 package, I'm getting a message that it wants to restart R to correctly install the package. So out of a lot of other
Is everybody getting that?
I got it.
Oh.
Not the same thing, I think it's already installed.
Oh yeah, if it's already installed, then you don't have to reinstall it.
So ggplot2 evaluates you as a person. See if you're
All right, so.
That's right.
Yeah, so ggplot2 is like the major plotting data visualization package in R, because it lets you change just about anything on the graph. So if you want to change the size of your legend, you want to change the colors, like you can change basically anything. So ggplot is good in that respect, that it has it gives you a lot of freedom to change things, but it is a little bit more complicated in that you have to know what to change and how to change it. So that is, if you wanted to just do a quick scatter plot, then you would just use like the plot function that comes with R. It's literally called plot. Then that's just a base function that'll just give you. While we're waiting, we can just do plot $experience by $num and run that, and then it'll give us And again, you can't really see it on mine because for some reason the display, having it plugged in, it just makes it really small. I don't know why. But so that just gives you like a quick scatter plot. So there are built-in functions, but then they're not easily changeable. So ggplot is nice because you can change it. Is everybody who doesn't have ggplot ready to go yet? A couple of you still? Okay. So the way that ggplot works is you start with a base part of the graph, and then you can add things to it. So we'll start by saying ggplot, which is the function, and then we say the data that we want to graph. So we're going to do data D, like the data we've been working with, and then you use this AES function inside of it. AES stands for aesthetics, and you're telling it what you want to go where. So we'll say x equals, I don't remember what I previously said we were going to graph, gender. So x is going to be gender, so gender will be on the x-axis, and y equals experience. And then, so this is just going to set up what the graph is going to look like. And then if you want to, that's just going to set up your graphing environment. It's going to put gender on the x-axis and experience on the y-axis. So then we want to add something to that. So you're going to have a plus sign on the outside of this ggplot function. The reason why they do that is so that you can, I could have said, I could save this whole thing to an object called plots, and it'll run. And then I can do plots plus what I'm going to do next. So the reason why you have the addition is then I could have a graph that I like, but then I want to add something to it, so I can just put a plus after it, so it's on the outside. So plus, and then we're going to use stat summary. So stat summary is a function that gives you the aggregation or whatever. It's going to do something to it. So in this case, we're going to take the mean because we're going to do a bar graph. So we want it's called fun.y. So your function that you're doing to y. So our y is experience. So the function that we want is mean. And then in this case, we're doing geom equals bar. So geom is what ggplot calls its different types of graph things that it puts on the graph. So there's geom point, which is just like a scatter plot dot. There's different things. So in this case, if we want to make a bar graph, it's geom equals bar. So if we run that, then it should give us this bar graph where it separates gender and experience. It shouldn't everything shouldn't be so small on yours, but you should get that as a basic bar graph. Any questions on getting that? Do you want to see the code again in case you are still copying? Any questions on that? Okay, I'm just going to do one more graph, and then I'll leave time for some questions if you have questions on whatever. So let's do a box plot this time. So we'll do ggplot, and then again we're using data D, AES, and we'll tell it the aesthetics that we want, which in this case we're going to look at software on the x-axis, y equals years, color equals color. So the reason, we'll do color equals gender. I remember why I didn't do colors because there were too many. So the color is going to separate it into the colors on the graph are going to be based on gender. So I'll show you what that looks like in just a second. So then once we have that, we can do geom underscore box plot. And when we run that, it shows up with the different colors being, and you can't see it because it's small because I have it plugged in. But so female and male are different colors. So this is female and this is the male for that particular software. So let me show that code again. Any questions on how I'm getting, why I'm putting this AES or why I have this plus geom box plot or anything else on this graphing? Yeah.
Is there a situation where something's going to go in those last parentheses brackets after box plot?
Geom box plot is a function that is telling it pull from. So okay, so there is a time where you would have this something in there if you were going to put a new AES in there. You can, instead of putting the AES in here, you can put it in here if it's like specific to the box plot. I don't do that and haven't made it such a complicated graph in a long time that requires me to have different AESs. So I suggest just stick with your first one and then just throw geom box plot on there and not bother. Do you have any reason why you would put anything in there?
Like change the size of the box plot and put it there. So that first plot function where the AES software year gender is, everything that comes after that will inherit those aesthetics unless you tell it otherwise. So
Yes.
if you put the size change in that, then the entire plot would change. But if you want to just change the size of the box plot, you would put it in the empty parentheses instead.
Right. So if you have multiple pieces to your graph, so if let's say I put a box plot and then I want to put like a jitter plot over it, I can like add the points to it separately, and I can have different characteristics. So if that explains.
So the first plot function draws the background, and then the box plot function puts the box plot on that, which is why you can change them independently.
Yeah. Okay, so that's all I have for today. I know I threw a lot at you guys, so I'm sorry for that. And you could, honestly, you'll never know all there is to know about R because new functions come out every day. So this is something that it's like learning a new language. When you learn Spanish, when you're a native English speaker, you can't learn it all in 3 hours. So I expect that you guys will have questions, and feel free to email me. And if you have any questions now, I'm going to stick around for a while if you guys have any individual questions that you want me to go over. Does anyone have any general questions about stuff that we have gone over today? Sarah?
Can you talk a little bit more about saving like R as projects versus like the individual scripts?
Yeah, so this is where your projects are up here. So as you can see, I'm working in a project called R Workshop, and I have all these other projects of things that I'm working on. So when I'm working on different projects, I make different R projects. You could just work in the same thing. The reason why I don't do that is because that way if I want to go back 2 years later, I want to be able to pull out and have everything that I was working on for that project with that project. So you can just go here and hit new project, and it's asking me if I want to save what I'm working on. So yes, save that. And it'll it'll give me options where I can either create a new directory, or I always do this existing directory, which is just you make a folder, put it in that folder. That's the one I choose, but you can make a new directory also. Any other questions on, yeah?
What's your favorite quick reference? So if you
Favorite?
don't know how to do something.
Oh, okay, yeah, I meant to talk about this. Google is your friend. So anything that you are doing in R, somebody else has done. So the chances, especially when you're first starting out, the chances that you're doing something that nobody else has done before are very slim. So if you Google it, you are most likely going to find code. The R community is super, super helpful. Like they want, like, they have the knowledge about R and they want to help other people. Like they figured out this certain way to do something, they want to tell other people to be able to do that same way. So usually when you Google it, you can find what you're looking for. I did look up this, it's called R cheat sheet that I was like looking up for today, just to see if there was like a quick thing that told you like different, I don't know if you can see it that well, but it kind of just goes through like, you know, here's what a for loop is. So I just Googled R cheat sheet and it was like the first one to come up. So it's called base R cheat sheet. And so this is just basically like when you're learning R, it gives you like the easy stuff. But when you're at the point where you kind of already know all of this languagey stuff, you know how to communicate with R, you know, but you just need to know what the function is that does something. That's when I always Google. I'm like, okay, I'm trying to do such and such, Google that, and it'll come up with what function does that. So Google is an important piece to learning R, is to Google.
Any package that's submitted to CRAN also, like, they require them to have, like, a PDF instruction manual. So if you're used to, like, MATLAB documentation, where, like, you can look up a particular modular extension or something, and it'll have, like, a list of all the functions. Any CRAN package will have that. If you get something else, it may not, but all the ones that we have will have to have that. So
Yeah.
you usually Google it and get a PDF that pops up.
Yeah, that's also usually what comes up when you say, like, function that does such and such, then usually what comes is that PDF written by the authors of the function. Yes?
So inevitably, when you're Googling, you may end up at either a site called StatExchange, right, or the UCLA website. Those are two very good resources to go to look for answers for things that you get stuck on.
Stack Overflow has, I think, a lot
Stack
too.
Overflow as well. But search those sites before you ask a question.
Yes.
If you're asking a question that's been asked like 100 times, you will be beaten down and made to feel bad about it.
Yeah, definitely 99% of the time somebody has done it before. So that's always a good option, is to Google it.
Can you email us your script that you were copying from?
Sure. Yeah, I can do that.
On a separate note, everybody at FSU has access to lynda.com, and they have a whole bunch of stuff on R that you can use there as well. So if you have, like, there's a 2.5-hour tutorial on data visualization in R with ggplot2. I know that you're talking about doing something like that. So there's just a whole bunch of options in lynda.com as well.
That's
It's
great.
free for everybody that's at FSU.
What.com?
Lynda, so if you log into your FSU account and you go to resources, there's a lynda.com option. And so you can click on that and then you just use your login credentials, and there's a whole bunch of stuff that you can look at on there.
Anything else? Okay, thank you.
Yay, thank you.